Okay, it's time for us to finish off this question and find the angle AXB. Let's go to our Google SketchUp version of this, and we last worked out AX, so we've drawn that in. Let's put in XB and have a look at that. Now, if we remember, we worked out AX in the last part of the question. We found AX was equal to 2.5. So we could write this down as 2.5 and this down as 2.5, knowing this basis 4, and use the cosine rule to find this angle. Once you've got three sides, you can find any angle of any triangle using the cosine rule, but we might not have the cosine rule known to us. You might only know the standard SOHCAHTOA trigonometry rules. Now we can still do it using those. If we draw this down, okay, and we create a right angle triangle here, and if we colour that in, we get this. There's your right angle triangle. We can know this side, we know this side, and we know this side. So we can use trigonometry to find this angle here. And then once we found that angle, we can find this. We know this angle because it's just the same. Therefore the whole angle is double. So let's go ahead and do that. So let's label up our triangle. Well, here's our angle here that we're going to deal with. Okay, we'll call that theta the angle. So this is our adjacent, this is our opposite, and this is our hypotenuse. Now earlier we used the tan. What I'm going to do now to find this angle, what I'm going to do now is I'm going to use two values different. I'm going to use this value here, 2.5, so you get to see me choosing a different formula. We know this is 1.5. Actually, we do know this is 2. Well, let's say that we're going to use the opposite and the hypotenuse. So these are the two that we're going to use. The hypotenuse here and the opposite here. So which of these formulas connects our opposite and the hypotenuse? Well, O and A was tan, which is the opposite and adjacent. Not that. Not adjacent and hypotenuse. But the opposite and hypotenuse in this formula are connected. So we're going to use sine to do this question if we use these two. Notice if we use adjacent to hypotenuse, we could use the cosine, and we could use the opposite and the adjacent, and then use the tan. But we're going to use sine just to see how another one is used. So let's write that out. So we know that sine of our angle equals the opposite over the hypotenuse. So sine of the angle, in this case, will equal the opposite, which is 2, over the hypotenuse, which is 2.5. Let's get our calculator in. So 2 divided by 2.5, we should know what that is, 4/5. Now we won't necessarily know how to find theta. We do shift sine, we do inverse sine, because we've got sine of theta equals 2 over 2.5. So we're going to inverse sine the answer to get the angle, and we get 51.13 degrees. So let's write that in. So we have theta equal to 51.13 degrees, but we want to find AXB. Excuse me, sorry, just a bit of rubbish drawing there. I'll just get rid of that and put my cursor in a sensible place this time. Keep an eye on what I'm doing when I'm writing. AXB. And that's going to be just 2 times 51.13 degrees, so let's times that by 2. Notice I'm going to use the whole calculated display. Never use your rounded value. Okay, and you only round at the very end. Always use all your working. And you get 106.26 degrees. So to three significant figures, that's going to be 106 degrees. So let's write that down. 2 3 significant figures. 106 degrees. 2 3 S F. And that has a final answer.